guys, in this video we're going to talk about end behavior. We've covered the domain and range. We've talked about the fact that it goes to positive and negative infinity. But what does that actually look like? What does that mean for the very extremes of these functions? Let's go ahead and get to the notes. All right, end behavior, the last lesson of Unit 3. Let's go ahead and get to it so you guys can get started getting ready for your test. I know you're so excited. Okay, so the last characteristic we use to describe a function is end behavior. End behavior describes what happens to the y value as the x value approaches infinity or negative infinity. So as those functions get to their very extremes, what is happening? So there's a few different ways that we ask about end behavior. This is another one of those examples where math can't decide just one way to ask something. We have to ask a bunch of different things. So sometimes we write this, which looks confusing, but all it means is as x approaches negative infinity, so as x goes to negative infinity, y goes to blank. So what's y doing as x gets smaller and smaller? The pairing with that would be as x approaches positive infinity, y approaches what? So as x gets larger and larger, what is y doing? Another way that we might ask is we might say as x increases, y blank. So as x goes up, what does y do? As x decreases, y blank. And then the last way we might say it is as x increases, f of x, because you guys know f of x is the same thing as y. And as x decreases, f of x blank. That page number looks like it's an answer, but it's not. That's not the sort of answer you'll see there. So f of x does what? So there are some things we can expect. As always, there are some patterns to know. With linear, one side's going to go up to positive infinity, the other side's going to go down to negative infinity. You can bet on that every single time. With quadratics, both sides are going to do the same thing because it's a u, and it's either pointing up or it's pointing down. With exponential, these are the weird ones this time. One side is going to go to either positive or negative infinity, depending on what it's doing, and the other side is going to approach the asymptote. All right, so let's see kind of what these patterns would look like and how the questions would be asked. So this first one, we've got a linear function because it's a line. It says as x approaches negative infinity, y blank. So what that means is I'm going to look at my graph, and I remember x is negative infinity over here. So as my x values go this way, what are my y values doing? Well, as x is getting smaller, y is going up. This thing is pointing upwards. So as x approaches negative infinity, y is going to approach positive infinity because my y values are getting bigger as the x values are getting smaller. As x approaches positive infinity, so as I go to the right, my y values are getting smaller, so my y values are approaching negative infinity. So I would put negative infinity. And that's all there is to it. All right, so let's look at a quadratic. As x increases, so that's on this side, as x is getting bigger, y is also increasing. The bigger the x value is that I plug in, the bigger the y value, and it's going to keep going up and trying to get to positive infinity. As x decreases, so as I plug in smaller and smaller x values, this thing is also going to get higher and higher. So it's also approaching positive infinity on this side. So as x decreases, y also increases. So no matter what x is doing, this y value is going up. So the other way I would have asked that is as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y also approaches positive infinity. So make sure you're thinking about these and thinking about what's happening at the arrows, what's happening to the y values on either extreme of this function. All right, so we have an exponential curve here. And this time I asked it as x decreases, f of x blanks. So as x decreases, as my x values that I'm plugging in get smaller and smaller, this thing is going down. But it's not just decreasing this time. And it's not hitting negative infinity because it's not pointing straight down, and it's not even going to get down to -4. So there's no way it's going to get to negative infinity. Instead, as x decreases, f of x is going to approach -3. because that's the value of the asymptote. Remember, I told you to expect with exponentials that one side is going to approach one of the infinities, the other side will approach the asymptote value. So in this case, -3, because it's trying to get to -3. It's never going to get there, so it's just going to keep getting closer and closer and closer as x decreases. As x increases, so as I plug in bigger x values, this thing is going to get higher and higher, and it is going to approach positive infinity. Or you could just say it will increase, okay, because it's going to keep getting higher and higher, and there's no limitations to that. All right, hopefully that makes sense to you. You can go ahead and try some U-tries, make sure you understand what's going on, check your answers, and then start getting ready for your last mastery check of Unit 3. Good luck, guys.